Okay, so a question. The root mean squared of an oxygen molecule, remember oxygen's one of those diatomic ones, so it's O2, in a container of oxygen gas is 625 meters per second. What is the temperature of the gas? Okay, but first, before we answer this, we're going to have a quick look at what we actually mean by root mean squared. So root mean squared is just the square root of the average velocity squared. So the average velocity of the gas is 0 because it's just as likely to be moving in the x direction as the negative x direction. So in the x or the y or the z direction, the average velocity is 0. So the average velocity is 0. So we need to square the velocity and then take the average. Okay, if we were to find the RMS speed of these particles, let's assume these are in meters per second in the I direction, then what we need to do is square each of these numbers and add them together, divide by the number of numbers that there are, and then take the square root. Okay, so what we do is 1 squared, which is 1, plus 2 squared, which is 4, plus 4 squared, which is 16, plus minus 3 squared, which gives us 9. And now there's 1, 2, 3, 4 values there, so we divide by 4. Then we take the square root. When you do that on the calculator, you get 2.74. So the RMS velocity for these values is 2.74. Okay, let's now go back to this question where we've got the oxygen molecule and its root mean squared velocity is 625 meters per second, and we're asked to find the temperature. Okay, so we've been asked to find the temperature and we're told that the root mean squared velocity is equal to 625. So we can say that the average velocity squared, which is the square of the root mean squared velocity, 625 squared. Solving that on the calculator, we end up with 390,625. We'll keep all our significant figures for now. Now, temperature is equal to 2 over 3 kb times the average kinetic energy. So we've got this velocity squared. Kb is just a constant that we can look up. What we need to work out is the mass of an oxygen molecule. So the mass of oxygen, if we look it up on the periodic table, oxygen has an atomic mass of 16. So to get the molar mass, it's a diatomic molecule, so we need to times this by 2. And this is grams per mole. So let's put that into kilograms. We times it by 10 to the minus 3. And then we need the mass of a single particle, not of 1 mole of particles. So we divide it by Avogadro's number, 6.022 times 10 to the 23. When you do that on the calculator, you end up with 5.3138 times 10 to the minus 26 kilograms. Okay, so now we're ready to substitute everything in here. The temperature is equal to 2/3 over kb, so that's 1.381 times 10 to the minus 23 times a half times this number, 5.318 times 10 to the minus 26. Times our velocity squared, which is this number up here. Okay, we solve that on the calculator and we end up with 501 kelvins. Okay, and 501 kelvins looks like a reasonable answer. It's of the same order of magnitude as room temperature, so that's what we'd expect.